you will notice that your homework is due on the 5th, so Thursday next week, okay? Your homework and your quick solve, so everything is due before the test. There's nothing getting turned in at that time. Yeah.
Is the test really short or something that it's only a 2-month period?
It's a lot of paper, it's a short test. It doesn't take very long, but there's spacing that occurs. So enough said about that. Is there any problems from your homework from yesterday that you would like to take a look at? Okay, then the very first problem is actually for you to do. It's what we did yesterday. So just the first one. I will start writing a few things up here, but I want you to calculate it and get that on your own. I will draw the picture for you, but feel free to practice that on your own as well. So folks who are in your note packer right now, there's been a few of you, and I don't blame you too much because I did make you grab this white piece of paper first. But you're in your note packers right now, and the numbers that we're going to use for this, we're looking at the math ACT scores. So my score goes right there, so 28, and then I'm looking at minus 20.4, that's the mean, and then we got 5.6. And when we calculate that, what do you get? Well, you get, I do want to talk about that. You get 1.357. We do round. Not always, you don't always round up, but we do round up here. And so the thing is, you got to be watching because your Z table does not have 3 decimal places. Okay? It doesn't have thousands. So we are going to go 1.36. And that gives me what percent?
91.
Yeah, all right. So we would be in the 91st percentile. That's how it looks. What questions do we have? Yesterday, this is what you did. And today we're going to go backwards. So we're actually going to undo the entire process that you just did. So what was the last thing that you just did? You found the percent in the table. So folks, actually on the next problem, that's where we're going to start. So this is how it works out. On this next problem, it says you know, what happens if we switch things around? What do I need to score on my composite ACT in order to be in the 80th percentile? So they just gave me a percentile. So instead of starting on the outside and working my way into the Z table, I actually just look for what is the 80th percentile as a decimal. Where did that 0.5 come from? I like the 0.8. So we're going to go with 0.8. So 80th percentile is 0.8. Now, I go to my Z table. Is that going to be on the positive or the negative side? Positive side is good. So I go here, and I'm looking for 0.8. And you know what? We're never going to find it. We're going to find 0.8, and then there's going to be some other numbers. So we have to find whatever is closest to 0.8. So I start looking, and I see 0.80 here. That is getting bigger. This is getting smaller, so I go to the left. This one could work, but I'm actually going to go one more as well. Which one is closer to 0.8? The 79. Yeah. So if you look at that and you're like, Nichols, no idea. How? Like, what am I supposed to do with that if I don't know? If I look at it and I don't know, all you do is you just go over to your calculator and go 0.8 minus one of the numbers and 0.8 minus the other number. And I did the absolute value here, but I just look which number is smaller. And in this case, this is smaller, so that means that's the correct number to use. Okay? I actually never really do this calculation, and I don't really need you to either. But if you would like to, if you're not seeing it, that's fine. You can do that. So we are going to use this number right here. And so, again, I work backwards. I look, what row is that? What column is that? So that's going to be 0.84. That's my Z-score that I need to be in the 80th percentile. So we go there. And so 80th percentile, my Z-score is going to be 0.84. What's my score? Don't know. So I don't know it, so I'm going to put an X right there. Then I put minus my average. I'm looking at the composite ACT, so my average is 20.7. And then I divide by my standard deviation, which is 5.9. Okay, when we solve problems, like when you were solving stuff in math or in Algebra 1, there's always something else. There's always like something we would throw at you that would make it a little bit more tricky or like change it up just enough where you're like, I don't know if I go in this direction or that direction. Folks, we don't do that with this. If you are looking at this, once I get to this formula, I will always do the same steps. I always do step number 1, which is simply going to be multiply both sides by my standard deviation. And so please focus on this. When I multiply this by 5.9, that cancels out. I'm never going to multiply this 5.9 by 20.7 or whatever number is there. It's just gone. And then I come over here and I do the same thing, times 5.9. So grab a calculator and get typing. Let's get that number. And it is. So 4.956. And that equals x minus 20.7. Please tell me what we do next. Okay, we add the 20. So I'm going to go plus 20.7 to both sides. And I end up with 606. Yeah. What I will say about that answer is if we look at the numbers that are given to us, they're all given to us only going to the 10th place. So I'd round this to the 10th place. but it's not like we always round there. It's based off what information we have. And so on the test, I will tell you what to round to. Okay? So I would round this to say this is going to be x is equal to 25.7. And let's think about that. I have this little picture here. I have my average, which is 20.7. My score that I just got is 25.7. And I'd be shading to the left. So could that possibly work? Yeah, it would be about, it could be the 80th percentile. It's above 50. So that's like our generic check that we can do to be like, okay, it works or it doesn't work. And that's what we got. So, questions? Let's start the next one. 40th percentile. I'm going to start with the picture this time. Doesn't matter when you draw the picture. It is helpful to start with. But I got my average. 40th percentile is to the left of that average. So should my score be above or below the mean? Below. It should be below. And so we're starting looking at some stuff here. 40th percentile, what is that as a decimal? 0.4. Is that going to be on the positive or negative side of my z-table? It is going to be negative. So I get over there. And 0.4. Down here, down towards the bottom half of your z-table. So I start looking at stuff, 0.47, 47%, too high. Keep cruising a little bit. I see a 0.39. I see another 0.39. I see a 0.4013. Looks like these two numbers are the numbers that I'm going to be taking a look at. Which one? 0.4013 or 0.3974? The first one? The first one's good. So I am going to take this number and I go to the outside of my table again. So I look here, so I'm looking at negative 0.2. Then I go all the way to the top, which is 5. So I'm looking at a score of negative 0.25. And then I got to fill out my stuff. I don't know what my score is going to be, so I'm going to put an X down. Reading, our average is 21.2, and our standard deviation is 6.9. And I'm going to let you calculate this one. So give me a number for that. It is the same steps as above. Multiply by the bottom and then add the other number across. Just giving you a head start. What questions do we got? Did we get it? We got to start there. If we didn't get it, I got to help you get there. So, is there any questions about how we got there? All right, the last one has just a little bit of a trick. So Z tables do not give you the top 10%, the top 20%. They don't give you anything at the top. They only give you percentiles, they only give you below. So we just have to read into that. So, you know, in the top 10%, if I look at this, my mean is here, that's 50%. Top 10% is like that. So if the top 10% is here, what is over here? 90%. So when you're looking at this, if it says the top 15%, then you're looking for 85 in your chart, in your Z table. So in the Z table, I will look for 0.9. And so let's go find 0.9. Let's get that, and then we can calculate it quickly. Who thinks they have it? Let's see a few more hands thinking they have it. Okay, let's find 0.9 in here. I'm going to tell you right now, it is in the upper right-hand corner or quarter of the paper. So 0.9 is what I'm looking for, so 0.9 with 4 or 3 zeros. So when I look for that, I'm looking right here. So I'm looking in the 1.2 row, and I'm looking in the 0.08 or 0.09 column. So which one is closer? Yeah, this one. So I take my two numbers. So I'm really looking at 1.28 as my Z-score. So I'm going to go there to the next page and put that down. And you calculate this one. And I'll be walking around, and please ask if you got a question. Number, the 21.2 and the 6.9 and that. That's coming from over here. Oh, okay. So I go to 6.9, multiply both sides, which really just cancels out here. And I go 6.9 times 10 to 0. Yep, so obviously, once it's right there. And then Yep. How did you do it? It's a wow.
Or would you give 27.7?
I'm just trying to get the normal. So.
Let's go.
All right, what's that answer? X equals 27.6. I saw that when I was walking around a lot, so I was happy to see that. If you did not get it, that's fine, but I do want to answer any questions you got. So is there any questions? Because we're going to kind of close the door on this. We're going to shift our gears and go to something else. We all right? So please realize, like, the big thing from today is this. This is the most important piece. The next thing we're going to do, we still looked at it, it's still helpful, but if I'm telling you what you really need to know. I'm telling you that yesterday and today, right now, those two things are super important. They affect you through this entire year. So please make sure you're focused on that stuff. The next thing we're going to do is look at a medical chart. And we're going to understand how to read it.
No.
Are there any CNAs in here? Not. All right. CNAs.
CNA, what is that?
Certified nursing assistant? Yeah, that's actually right. I was like, maybe there's some other meaning, but that's pretty much right.
Jackson,
All right, so here we go. So at some points in your life, you actually might see one of these. I always kind of chuckled at this one because I was like, I don't think I've ever seen one of these. And then I had a little baby, and then I saw like 50 of them. And I was like, okay, wow, this is fun. So the thing with these is they're pretty easy to understand, but they do look kind of complicated. And so you really just draw two lines and you answer your own question. So this is how it works. So this first problem, this is for boys between the age of 2 to 20, and it says being above the 95th percentile in weight might indicate a need for dietary or exercise changes or possibly some other health issue. What weight is the 95th percentile for a 15-year-old boy? So this is how you read it. You first look, this is for height, this is for weight. So I slide down to the weight. Then I just find the age. So 15 years old is what I'm looking at. And so I just draw a line going straight up at 15. Now, some of you are a little like leery of actually drawing the line. You like to just slide up, and that's fine. I don't care. But if you're starting to get lost, just draw the line. Okay? So the next thing it says, we're looking for what is the weight for the 95th percentile. So these curves, these lines are labeled. There's 95, 90, 75, 50, 25, all that stuff. So we just find 95. I go back until I hit my first line. And now I draw a line horizontally across. And I'm not dealing with kilograms, so I'm going to go with pounds. So I have two lines where they cross. Yours are probably going to be more accurate than mine because my picture is pretty blurry and you have it right in front of you on a piece of paper. And so when I look at this, to me, it looks like it is approximately 173. So I'm going to put 173 pounds down. If you have 174, that's also fine. That's it. So we're going to do another one. Just to make sure we got it. So a steady decline in height percentiles over the years may indicate some growth issues. What is the approximate height for a 17-year-old in the bottom quartile, the lowest 25%? And so, you know, this is weight. Not looking at weight anymore. I'm looking at height. So I slide up, and I'm looking at someone who's 17. Now the age is on the top and the bottom, so I go to 17. Slide this down. And I, again, just find the percentile that I want. So I'm looking for the 25th percentile. So I'm here. I slide straight across. And it is 67 inches tall. So my brother is a science teacher, so he also sometimes does stuff like this in some of his classes. But so our sister-in-law is very short, so we actually use one of these charts to show her how short she is statistically. That went over very well. It was very nice. We get along, but it was enjoyable. So, anyways, any questions on the chart? Yeah, not too bad. So, we're going to skip this portion of the question because I'm going to help you just do the problem on your homework, okay? And then we're going to talk about, does the standard deviation for weight stay the same or change throughout the year? How do I know? And what I need you to realize is standard deviation is just a measure of how things vary. So if your standard deviation is a very big number, your data is spread all over the place, okay? So what that means is, for example, your class, if your standard deviation is like 15, it means you had some people getting really, really good scores and you had some people getting really, really bad scores, and you are just spread out everywhere in the middle. Like basically nobody is scoring like the same thing. If your standard deviation is like 2, it means that basically all of your data set is super tight together and there's like no variation. Pretty much every single one of you got the same score. So that's what it's talking about. It's talking about the variation. So if I look at this, does the standard deviation for weight stay the same or change? Well, right here is the weight. And if I look at it, right here it's really close together. And it starts getting more spread and more spread and more spread. So does it change or stay the same? It just changes. Okay? It doesn't ask us how much it does. So I'm going to put change. And how do I know that? It's just the spread of the data. Questions? Your choice. All right, last page, and then I will help you on one homework problem. So the last page just talks about skew. Skewed right, skewed left. And it talks about some other stuff too. So we talk a lot about normal distributions. Basically, I just want you to realize there is other distributions out there. Skewed right and skewed left are pretty important to know about. And so won't dive too much into that. But I just want you to realize that we do have other distributions. Not every single thing that we have is a normal distribution. Now, these two are the ones we talk the most about because you might actually see them at some point in your life. So I have these little diagrams here. You don't have them on paper. You don't need to write them down. But if I take a look at this one, this is going to be skewed right. And you're looking at that and you're like, Nicholas, that data is on the left. I understand that. But you almost have to imagine you're like punching from the bottom of your desk up and through that desk. My right hand would be coming through the board. So it's skewed right. That's how they decided to do it for the stats people. Long before I was born. So here's the thing that matters for you. Keegan, what's your dream job? Amir, dream job.
Not work.
That is a good dream job.
Very difficult.
Ellie, dream job. Lainey, dream job. A pilot. All right. So, if you are a pilot, do you know how much they start making? No idea? Okay, we're going to just make some numbers up then. So, I do know a captain can make up to like upper 100s, 200s, somewhere up there. Like, they do make very well. But here's the deal. So, it doesn't really matter what job I guess you're thinking about, unless you're not working at all. Then I don't know if this applies. But companies will always advertise and say, hey, you know what? Our average salary is like $65,000 or it's $70,000. Doesn't sound too shabby. Except they can skew their data and they can manipulate it to show what they want. So they can say their average, their mean, is $65,000. Even though you and basically everybody else that works there is only going to make $40,000, except for maybe like 10 people who, let's say, make $700,000. So these few people take that, slide the average all the way over, and leave you back here. So you might be looking at that and you're like, wouldn't the mode, the number that occurs the most frequently, be the better piece, the more truthful piece? Yeah, but it sucks for marketing. So when you are given data, realize it can be manipulated. They can show you one test here or another test here, and they can choose to show you whatever they want you to see. So you have to understand what is the data actually telling you. Questions? All right. You can keep your notes, you can shut them, whatever you want. But I want you to go